In the previous video, I said that the range of the function basically tells us the possible y values that that function can take. So we want to inspect this function and we want to ask ourselves the question, well, what are the possible y values that this function can take? But for us to figure that out, we need to use the x values because the x values give us the y values. Now, this method only works for rational functions. Like I said, a rational function is a function with a numerator and a denominator. So don't try and use this method for other functions. There are other ways of handling other functions, which I will probably look at as well. So if you have this function here, let's inspect this function and let's say what happens to what happens to the function when x is 10? Y is equal to, well, what's y? I'm going to use Desmos.com here. It's a calculator website, and as you noticed from my previous videos, it's also a graphing website. So 8 divided by, our x in this case is 10 minus 2 and plus 2. Our y is 3. Our y is 3. So when x is equal to 10, y is equal to 3. Let's put in x as 100. The reason we're going up and up is because x is greater than 2, so x can be anything above 2. So what we're trying to figure out is, as our x values become bigger and bigger, what's happening to our y values? Let's plug in 100 over here. We get 2.08. Y is equal to 2.08. What about when x is 1,000? Y is equal to 2.008. Now what happens when x is 10,000? Let's put in another 0 here. Y is 2.0008. I hope you're starting to notice a pattern here, okay? What about when x is 100,000? Let's add in another 0. What happens? 2.0008. Let's add another 0 when x is equal to 1 million. Let's add in another 0. You can see what's happening here. Now we have 1, 2, 3, 4, 5 zeros. Now, I hope you can see here. Now let's plug in a very ridiculously large number. What do you notice? Let's add another 0. The number becomes bigger. 2.001. It becomes 2. 2. 2. 2. 2. 2. Our y value is stopping at 2. Our y value is stopping at 2. You can see here, we started off at 3, and as we kept on increasing the values of x, our y value was approaching the number 2, 2.008, 2.000008, and so on and so forth, until we plugged in a ridiculously large number, and y remained as 2. So what is the conclusion? As x approaches infinity, y approaches 2. X approaching, you all know what infinity is. Infinity is a very big number. Basically what we're trying to say is, as the x value of the function becomes so big, as it becomes bigger and bigger, our y value is approaching the number 2. Here's another thing to observe. As x is becoming bigger and bigger, your y is becoming smaller and smaller, right? Your y is becoming smaller and smaller. So if your x is becoming bigger and bigger, and your y is becoming smaller and smaller, but your y is approaching 2, what does that tell you? It tells you that the smallest value of y is 2. Because as x is becoming bigger, y is becoming smaller. But y is approaching 2. It's not becoming smaller than that, which means that the smallest value of y in this function is 2. What does that tell you? As x is becoming bigger and bigger, as x is becoming bigger and bigger, y is becoming smaller and smaller. But if y is going to stay at 2, it tells you that y is not going to become any smaller. Y isn't going to become any smaller. So the smallest value of our function y is going to be 2. Is going to be 2. But is it ever going to reach 2? It's never going to reach 2, because for y to reach 2, x has to reach infinity. X has to reach infinity. But you can never reach infinity. Infinity is a number that you cannot reach. The only way this is actually going to be equal to 2 is if this reaches infinity. But you might be asking, but the calculator says 2 here. The truth is, the number that you're approaching is so close to 2 that your calculator is just going to round it off to 2. But this is not actually 2. This is 2.000000000 something, and then a 1 at the end. So this is not actually 2. That's the truth of the matter. If I was to do this just a bit, you have 2.00001. If I add another 0 here, another 0 is going to add here. But then your calculator is not going to give you all those decimal places, so it's just going to round this off to 2. So you're never actually going to reach the number 2. The only way you can reach the number 2 is if x approaches infinity. So that's why we don't have an equal to sign there. That would make it wrong. That's why we just say y is greater than 2. Because for y to be 2, x has to be infinity. X has to be infinity. So we've seen from this function here that as our x values become larger and larger, our y values are becoming smaller and smaller. But as x becomes so big, y is approaching 2. It's never going to reach 2, but it's approaching 2, as you see here. 2.08, 2.008, 2.0008, and so on and so forth. So y is always going to be greater than 2, and that is actually going to be the range of this function. F of x is greater than 2. It's f of x, not y. I just called it y, but it's actually f of x is greater than 2. So in the second video, I'm going to be explaining this idea a bit more. Until next time.